Welcome, this is Target 2.2. I started making some of the older unit videos and I wanted to start with this one because I think if you have not retaken it, this is a nice one that really is either going to be a 2.5 or a 4. Very unlikely that I give too many grades in between because typically students who are getting 2.5s and went for this option of a 4 accidentally messed up the degree, and that caused them to get one of the two problems incorrect. So one, it's a really short target. Two, it's also, I think, quite achievable if you make a quality note sheet like the one I'm providing in this video. So let's start off. First things you need is you probably should have this box that I'm going to highlight with my laser right here. We're going to fill it in together, and it's a good idea that if you weren't quite sure, because maybe you missed the intro to it, these are the 4 possibilities our polynomial functions can look like. They fall into either an even degree. So when I figure out what the degree is, the answer is something like 2, degree 2, 4, 6, etc., even. Or it's an odd degree, which of course would be something like degree 3, 5, I guess technically 1, but I don't really do that, 7, etc. So just even and odd literally from the degree. And then the other category that we have to look at is the leading coefficient. And those can either be positive or they can be negative. Do I have another color? Yeah, negative. And so I'm always looking at both the degree and the leading coefficient. So for each of these problems below, we'll kind of make sure it's clear what those two things mean. But inside, you should have what they look like. So if I'm even negative, I'm going to both be down, sorry, I got a new tip to try to make it quieter, but sometimes it's harder to write. So I'm going to zoom in. Both down. It's too big, I think. Both down. See, that tapping noise can bother some students. And both of these are going to be going towards negative infinity. So both of my answers, we'll get to that in a minute, are negative infinity. And that's when we're negative and even. If I am positive and even, then I'm going to be both up, which of course would be the opposite, positive infinity and positive infinity. Lastly, we have our odd category. Odd, I like to think of as opposite. So if I'm odd positive, then I look something like my arms are wacky, waving and pointing in this very specific direction. The left is down, or negative infinity, and the right is up, or positive infinity. So I think it could be helpful to kind of be like up, positive, down, negative. And then in our negative, it would be the opposite. So my left is pointing up, left, up, which is going to be positive infinity, and right, down, or negative infinity. So those are the 4 possibilities for our end behavior. I'm just going to go over a little bit thicker on our directions because I think the picture helps a lot. So again, you can rewind to see it zoomed in a little bit if you need to, but I imagine your youthful eyes can see just fine. The other part of this target, by the way, if you just draw those pictures, you can get it at most a 2.5. So if you're someone who has lower than the 2.5, I find it to be very achievable to get to our goal, which is have every target at least a 2.5, by just getting the pictures down. And I can help you with the calculator reminder. If you're like, Miss Jenkins, the calculator is not showing me the graph, just raise your hand and I'll help you. If you're trying to go for the 4, so this is the technical way of writing, technical end behavior, it helps to know that every single time I'm looking for both of these. I need both. So let's kind of translate underneath what they say. This first one says, as we move left, or looking to the left, the graph goes blank. So you have to answer it based on which corner. So when we looked at these four corners over here, we said either both down, both up, left up, right down, etc. That's giving you this first clue of when we go left, which direction are we going? And so the other one, you have to provide both parts of these. And specifically, we need the comma statements because it's more than one piece of information. As we move, that looks like more. As we move right, the graph goes blank. And so what do we fill in the blank? The blanks are one of two choices. They're either positive infinity for up or negative infinity for down. So the blank, I'm going to remind you, is our turquoise position, our spot in our statement. And so you're just kind of copying and pasting. X goes towards negative infinity, comma, f of x goes towards your answer. One of these two things needs to go into that turquoise box there. So now let's see it in action. So as I said, we'll kind of go a little bit slower on what these words mean. So the first thing we need to tell ourselves is we need to know degree, which is the highest exponent. And it truly is that definition in this format, because when I see these plus signs and minus signs, it means that I have a trinomial. And so I'm in standard form. When I'm in standard form, I am straight up asking, what is the highest exponent? So let me get my laser. So I'm comparing 2, 18, and 16. So the highest exponent is 18. And since 18 is even, our degree is even. Now, we know that we're in this, let's call this number 1, that problem number 1 is in this first left-hand column. So now the second piece that we need to answer is the leading coefficient. I'm going to shorten that. And that is just the number multiplying with the degree. We'll modify the definitions when we get to the next problem because you'll notice that it is a slightly different presentation. So when I'm on this one, I found my degree to be 18, so I'm highlighting that now. Then the number right in front of it is 4. So our leading coefficient, our LC, is 4 or positive. So we now know we're even, positive. We are living in this bottom left-hand box. So to get a 2.5, this right here will get you a 2.5 for a grade. But if you do that and try your best at presenting the official or technical end behavior, so I'm going to go ahead and start pre-filling. It says I need both. So I'm going to instantly start writing x approaches negative infinity, positive infinity, comma, f of x goes towards, and then I have to maybe pause here and think a little bit harder about what I need. So when I told myself that I'm in the bottom left-hand corner of my answer key, I need both to be, both turquoise boxes. I'm going to go ahead and fill those so that it's the same. I need both of those to be positive infinity. That translates to they're both up. So this answer right here is to get a 4, to earn a 4. Now, of course, you can't just get a 4 with only one correct solution, so let's talk about the next one. The next one is in factored form. If I see these parentheses, it's trying to alert my mind here that I'm in factored form. So I have to kind of think about what would it look like if I multiplied it all the way out using the box several times, like FOIL, multiple iterations of it. So I have to think about, negative 3 times x plus 2 times x plus 2 times, oh my goodness, why did I choose such big exponents, times x plus 2, because there's 3 of these, thanks to the cube. And then I have x minus 1 and x minus 1 twice. That is what our definition of exponents means. So I'm going to choose a different color here. When we have something like squared, it's because I have 2 of those binomials. When I have this little 3, it's because I have 3 of those binomials. And so mathematicians don't want to expand all the time. That takes a lot of work. So what is degree in factored form? Well, degree is the total number of x's in the final product. Remember, the word product means multiplication. So as we multiply all these out, it's really just also thinking about the total number or counting. So how many do I have? I'm using my laser pointer. I had 1, 2, 3, 4, 5, or through our shortcut of understanding that multiplication is just this idea of the total number, then we can just add those. So I'm going to do 3 plus 2, which is 5, or odd. We have an odd degree. Similarly, we have our leading coefficient that we need to think about. That it changes slightly, although I would argue in this course is probably not going to be terribly more difficult than what's presented in this problem. Next year, of course, in pre-calc, we can kind of try to trick you a little bit more because you have a deeper understanding of what it means to be in factored form. But what we're looking for now is all of the coefficients multiplied together. So it's the same idea of multiplied together. The same idea of a product. We need a product in our answer here. So who are we multiplying? -3, 1 squared, oh sorry, that should be a cubed, 1 cubed, and then 1 squared. All of the coefficients, I'm going to go and read it again, are right outside. They're the ones without the x on the outside because I don't have a factor there, but I do have a constant, -3. And then on the inside, it's the one with the degree. So I have an x there. That means that I'm not the constant. I am the leading coefficient. So 2 is our constant. And then I have this x again. So they're the number multiplying with our degree here, just like our previous definition. And so we have those 2 ones that I have down here. So 1 we don't really care about. So our leading coefficient is -3. And that's probably how it would pop up too. It's just whatever number is in front. So our leading coefficient is negative. I'm going to have to get rid of some of these definitions, but I can maybe make this work. So now I'm going to go for the for real quick. I'm going to pre-fill my positive and negative infinity statements. And get my little turquoise. And then I'm going to be like, okay, where are we living? Well, I'm going to use the turquoise again. So since we are both negative and odd, we are now in this box. And so I'm ready to go ahead and follow that same order. Remember, we have our definition. It starts, I think it's helpful to realize that we read left to right. So, of course, left is going to come first. So our left needs to be positive. So I'm going to write positive infinity. Odd is opposite. So, of course, if I start with positive infinity, I'm going to continue with the other or the opposite and end with negative infinity. Hopefully that gets you caught up for that one target.